Hello and welcome to this video on rate of change. Okay, you should have already seen my previous video on rate of change or had some information in class about rate of change. And in this video, we're going to talk about determining if the rate of change of a graph is constant or variable. Okay, now this is very easy to do. It can be done literally by looking, but for full understanding, we are going to want you to write a little bit more than just say, I know the answer. I can tell by looking. Okay? So there's an idea that we looked at previously, and it said a data set of x's and y's is linear if and only if the rate of change is constant. And again, the rate of change was delta y over delta x. Okay? But if I don't actually have a data set and I'm looking at a graph, it's actually much easier. Okay? Because here's the deal. It says that the data set is linear if and only if the rate of change is constant. Well, that's very simple then, because if you're looking at a graph of a straight line, it has a constant rate of change. If you're looking at a graph that's not a straight line, it's not constant rate of change. So we'll go back here, and we'll take a look and realize that delta y over delta x is constant, means that the data set is linear, but we also said it was if and only if, which means if the data set is linear, delta y over delta x is constant. So really, if you just looked at a graph, you could tell if it's going to be a constant rate of change or not. Okay? In this one, just by looking, we see that it's linear. So that means delta y over delta x has to be constant. And I don't know what that constant is because I haven't done anything to find it, but I know that there is a constant for it. And then here, if we look at this second graph, this is not linear. So quite easily, quite frankly, we know that delta y over delta x is in fact not constant. And when something's not constant, we tend to call it variable. Not variable like it's a letter, but variable like varying. It's in fact means that it's changing. Okay? So again, very easy. Linear, straight line, going to be a constant rate of change. Not linear, not a straight line, means you're going to get a variable rate of change. Okay? So let's actually examine these a little more closely and give a little bit of, almost as if it's proof or demonstration of our knowledge set of this. Okay? So what we have here is the question, is the rate of change constant or a variable? Okay, well again we said we know that this is going to be constant because it's linear, but we're actually going to show it. Now to do that we have to be able to examine delta y and delta x on a graph. Okay, so for me to do that I just need to take a couple of readable points. I'll take this one, which is on the y-intercept, and then I'll sort of ride up the line and look for another. And here we've got a point here. And if I want to see, if I want to observe change here, I need to see a couple instances. So I'll take these 2 points to start, and then I'll take this point and this point again and take another look. Okay, so how do we measure delta y? Well, delta y is how much y change we have. Well, to go from this point to this point, we see that we're going up and we're going right. So our rate of change, we can actually show it with a triangle. This should be very familiar to the idea of slope because they are in fact the same thing. And we see here that our delta y is in fact 3 grids. And then our delta x is in fact 4 grids. Okay? So what do we have here? We've got delta y over delta x is equal to 3 over 4, which is equal to 0.75. Okay? Now, to know if something's constant, you have to look at more than one instance of it. Okay? I only have one instance of a rate of change here, so I'm going to measure another. And I'll take these second 2 points. And here I've got a delta y of 3, because I went up 3. and I've got a delta x of 4. So again, for the second circumstance, I've got 3 over 4 for my delta y over my delta x. It's equal to 0.75. So if you notice here, I'm getting a constant rate of change. From point to point to point, I still have a rate of change of 0.75. Well, that means that it's a constant rate of change. Okay? But again, don't lose sight of the fact that it is uber easy to know this, a little harder to demonstrate, but very easy to know just because the graph is a straight line, which means it's got to be a constant rate of change because it's linear. Okay? So I want to show something, just one more instance here to show you that this, I could have used any points that I wanted. And again, I'm going to write over this in pink, okay, so you can see it. I'm going to take this point here and this point here, okay? Now, if you notice, my rate of change here is going to be given by delta y this time, which is 6. And if I start at 2 and I go to 8, you can tell that the delta is 6. And then I'm going to go over to this point, and you see if I start at 0 and go to 8, that my rate of change is 8. Excuse me, my delta x is 8. Well, if you notice, too, if I did a third rate of change here to examine it, excuse me, showing that my delta y of 6 divided by 8 is still no shock that I'm getting 0.75. So what's it show you? I could have used any readable points from the graph that I wanted and still shown that the rate of change is going to be 0.75 no matter which points I use. Because again, the theory says for any x and y pairs in the set, you're going to get a constant when you do delta y divided by delta x. Okay? So one of the things we want to focus on here too, if you notice when you draw this triangle, in the first circumstance, kids, when they draw up, they see this 5, and they want to say, oh yeah, well, I guess that the delta y is 5. But don't forget, you didn't start at 0. You started here at 2. So from 2 to 5 is just 3. Okay? So you have to be careful when you're reading the graph that you're not reading the number off the axis, but you are, in fact, reading the amount of change from point to point. Okay? So let's take a look at this next example. And it says, is the rate of change constant or variable? Variable, again, means not constant. Well, I could look at this and, again, realize that linear equals constant and not linear equals not constant, also known as variable. So I could just look at this and say, well, look, this is not a line. Okay, I know the answer to this is going to be variable. Okay? But if you're asked to demonstrate that, you will be on a quiz, you're going to have to show rates of change and say, well, I've got this rate of change, and then I get a different rate of change. Okay? So again, what we're going to do is identify some points on the graph. Okay? I'll take the y-intercept again. You can't always, but in this case, it's good. And then I trace the line with my eye, and I just look for points where I'm, in fact, getting the graph to intersect some grid lines. Okay? So here's a point, and here's a point. Okay, so there's 4 of them. I just got to be able to make a minimum of 2 triangles, okay? So again, my delta y here goes from 2 to 4. It's not going to be 4, it's only 2. And then my delta x is going to go from 0 to 2, so it's going to be 2. So my first delta y over delta x, my rate of change is going to be equal to 2 over 2, which is 1. Now, I could look at any other combination of points I want. I could look at this rate of change, okay? I could look at this rate of change. Sorry, I'm drawing quickly here. Or I could look at this rate of change, anything I wanted, okay? So I think I will just look from here. I'm going to go from 10 up to 20, okay? If you notice, it's from 10 to 20. That means my delta y is 10. And then I'm going to go 2 grids across and realize that's going from 4 to 6 is 2. So my second delta y over delta x is going to be 10 over 2, which is equal to 5. Okay, well, I should have expected this phenomenon because when I first got a rate of change of 1, I would expect the rate of change to change because it's going to be variable because it's not linear. So it went from 1 to 5. So if I did these triangles, I would probably never get the same number twice because it's a variable rate of change. Okay? So the biggest thing here that we want you to see is how to be able to sort of write on these graphs and talk about rates of change. Okay? Being able to understand what does delta y and delta x mean on a graph. Well, again, we said it's going to be the same as slope. So your delta y is the rise. Okay? And your delta x is the run. Okay? And don't forget that because it's applicable to many ideas when we deal with slopes and rates of change. Okay? So enjoy, practice, and feel free to watch it again.